after I install this mic.
Is it red or green?
You tell me.
It's green, so it's
Green.
work.
Am I good?
Yeah, he's recording. Okay.
Awesome.
Oh my god. Bro, I'm up doing ready to go laying 160. Alright, fellas.
All right.
Josh has got stuff to do.
All right. Hello, everyone. Today I am talking about Android ROMs and what on earth they are, because I used to be really into this scene, and honestly, it's a really cool topic to talk about. So before we begin, I want to go over, this is what we're going to cover today. But I also want to go over what this talk is not about. And I think that's important to realize because I'm not going to be talking about a lot of app stuff here. So things about like how Android apps work or how Android apps communicate. That could be an entirely separate talk, or like 5 or 10, because it can actually be pretty complicated. I'm just talking about the system stuff and how rooted Android phones work, how Android ROMs work, and stuff like that. Before we get going, I'm going to cover a few. Like prerequisite topics that I think are kind of important to know before we actually get into what a ROM is and how to root an Android phone. So to start with that, I want to look at a few utilities. And I want to give that because unlike a certain fruit-based phone company, Android actually has a lot of really nice tooling that you can use to interact with the device from a developer standpoint. And the first of that is called ADB, or the Android Debug Bridge. ADB is something that is designed to be run while this Android system is running. So you could be either in a recovery, which we'll learn about in a second, or a Android, like completely booted into Android and use ADB. ADB can do all kinds of things, like grab a shell. It can transfer files. It can install apps on the phone, and it can even back the entire phone up. ADB is actually really cool, and if you haven't used it, I'd suggest giving it a try. You can find it in the developer menu of your Android phone, and if you have not enabled the developer menu, you can find that by tapping the build number a bunch of times, and suddenly a nice little thing pops up and says, congratulations, you're apparently a developer because you know how to Google how to enable that menu. Next up, we got Fastboot. Fastboot runs at a slightly different layer of Android. So when you have an Android phone, generally you're going to have some kind of firmware. That firmware on the device is what's going to initialize the boot up process. And Fastboot is your way of communicating with the phone before you get past that boot up process or get to the boot up process. So you boot into Fastboot and you plug your phone into a computer, and all of a sudden you can issue commands. These can be something like Fastboot OEM Unlock, which we'll cover in a second, or Fastboot Flash, or Fastboot Boot. One important thing to note here, Fastboot is usually locked down by default, unless you are OEM locked, OEM Unlocked, which we'll talk about in a bit. That being said, you can still usually flash signed binaries and stuff like that. Samsung has their own version of this that's completely different and really annoying, called Odin. The thing about Samsung phones is that they're just generally really annoying for this, and that's a theme that you'll probably see if you actually try to do anything with a Samsung phone and related to rooting, ROMing, or anything like that. Next up, I want to talk about the Android partition table and what makes up an Android phone. So we've got a bunch of different partitions here. This is generally what you'll see, how you'll see like an Android phone to look. If you took a look at the partitions, this is kind of what you'll see. I'm going to get into each of these in a second, but I really want to emphasize that you should never wipe or delete your vendor image. You have been warned. I will warn you again. To start, we're going to take a look at the recovery. This is the first partition on any Android phone, and it is used to install, update, or delete the cache and data partitions. So you can actually access this on your Android phone by, usually it's holding down volume down and power and then turning on the device. And you'll get into a menu that looks kind of like this. This is a simple menu, and this is because it's a stock recovery. But some of the options here you'll see, or may not see, depending on how far away you're sitting from the screen, is Reboot System Now, Reboot to Bootloader, Apply Update from ADB or SD card, wipe data, cache, or mount system. Again, this is a very simple recovery because it's the one that comes on the device by default. And also, one other thing you'll notice is that you can interface with this using ADB. So it does include support for that as well. So if you aren't holding down the volume down button when you turn on an Android phone like you usually are, you're not usually holding down the volume button, the thing that the firmware is going to look for is the boot partition. So the boot partition is designed to load the kernel and bootstrap the system. The boot partition is usually going to be signed by the manufacturer. If not, something's probably very, very wrong, or you're like rooted. And if it's not signed and you don't have an OEM unlock or something, the system's just probably not going to boot. It'll probably just throw an error message or give some kind of really weird warning. I saw an Android phone once that just like threw up a ton of errors and continued to let you boot for some reason. Not sure why. Usually that just stops you right in your tracks right there. At this point, the system will also start showing a boot animation of some sort. So if you've ever used an Android phone, this is the point in which you see like maybe your vendor of your phone, and then it switches to like kind of an interactive animation. That's the stage of boot we're looking at here. Next up is usually a vendor or modem partition. Not every phone has this, so I probably shouldn't say usually here. But oftentimes, these modem partitions contain information that is unique to this device, i.e. cannot be regenerated. If you're doing anything with an Android phone and want that Android phone to continue working, and you want to be able to, I don't know, connect to a mobile network or place phone calls, do not wipe this partition. In fact, you should back it up immediately once you root. Like immediately. This phone isn't even rooted at the moment, and I still have a backup of the modem partition somewhere. You have been warned, back it up. What's up, AT? Yes, you have been warned. Yes, that's why. PowerPoint suggestions is correct. Anyway, so next up, got the system partition. This is the root partition of the system, and this is also the most critical part because this is a part you will probably interact with. It contains all the system binaries, Android's like inner workings, and the Android runtime environment, everything like that. I also want to touch here on updates. This probably could have been a separate slide, but there are two ways that Android phones get updated at this point. One is with a AB partition system, and the other is with the recovery. Historically, the reason that the recovery is present on every Android device, and why it's still here, really, is because it facilitated updates. So when you go and update your phone and do a over-the-air update, your phone would reboot into the recovery, and the recovery would get a zip file. This zip file is specially formatted and contains update scripts created by the manufacturer that are also signed. The recovery verifies the signed binary and starts executing code in that zip file. And that's how the update process worked up till recently. A few years ago, the idea of an AB update was released. And this is really cool because I don't even think a fruit-based mobile company has this yet. But on Android, if you have an AB partition system, what that means is you have two system partitions that are the same. They are identical partitions. You boot off of one of them, and another one is just there. So when you go to update your phone, what's actually happening in the background is your system is updating the other partition while you're running off of a, so let's assume I'm running off partition A. When you update your phone, you're going to update partition B while the phone is still running. And then when you reboot into partition B, and then the update completes by updating partition A. And that's how that works, so that you can literally reboot into an update, and it'll work, even if you have, I don't know, a major upgrade from Android 11 to 12 or something like that. Next up is a data partition, and that's pretty self-explanatory. Where does all your stuff go? The data partition. Deleting this partition is almost a factory reset. I say almost, it's basically a dirty factory reset. There's one more partition, the cache partition, that is deleted as well during a factory reset. But deleting the data partition is a good way to lose a lot of things. So I would highly recommend not doing that unless you have a good backup. and the cache partition. Again, this is very self-explanatory. If all else fails, clear this. I have seen clearing the cache fix a lot of Android phones. And you can do it in the recovery. There's a quick button that says clear cache. If your system, Android system, is not performing like you'd expect, that's usually a good thing to try. Just jumping into the recovery and clearing the cache. You're not going to delete any data. It's not like this is going to delete anything at all. So it's a good option to try. You may have some issues with like packages being, you might have like a progress bar at the top of your phone that says something along the lines of Android is upgrading after you do this, but that's completely normal. So with those basics out of the way, let's start talking about actual custom ROMs. So what is a custom ROM? I keep saying that. I haven't really explained it yet. So remember that system partition we talked about. Your vendor or whoever makes your phone, your OEM, is going to put a system partition in that has their build of Android. A custom ROM is simply yanking that out and putting a different one in. That's it. So you have a different build of Android that has usually more features, sometimes a newer Android build, maybe newer security patches, usually less bloatware, and depending on if you trust your mobile vendor at all, more or less sus. So it's really convenient if you have, I don't know, a Samsung phone, for example, that has a very, very bloated ROM, and you don't want that. You want something more basic, more close to how Android is actually supposed to be. Also, never use Samsung phones to do anything with custom ROMs. Again, you have been warned that it's not fun. So common ROMs that you're going to see include the Android open source project. The Android open source project is basically just mainline Android. So parts of Android are open source. And I say parts of it because there is one major portion that is not. And we'll talk about that in another slide or two. So the AOSP is just grabbing all of Android source code and compiling it as is. It's basically the simplest custom ROM you can think of. It's really easy to build this. You can just pull down source code and do it. Straight from Google. Another common ROM I see on a lot of devices is Pixel Experience. So porting all the Pixel features from Pixels to other phones. And really the main custom ROM that you'll see at this point is something called LineageOS. LineageOS is a fork of CyanogenMod that no longer exists for reasons. I don't know. But it no longer exists. Lineage is basically Android open source project ++. It's got a few extra features built in that are super convenient. And it's honestly the most stable ROM that you'll probably see that's not AOSP. We also have Paranoid Android and Android Open Kang project, which are a bit older, but also like just different types of ROMs you can install. And obviously, this isn't a complete list. You're going to find all kinds of ROMs if you look around. So one other important thing to note here is that GApps is a thing that exists. Remember how I said that Android, not everything for Android is open source. The key component that isn't open source is GApps. And that's basically going to be your Play services. So your Gmail, YouTube, Google Play Store, anything that requires the Google Play Services package is included in the GApps package. And you will have to find that separately. Due to license restrictions, usually ROMs can't release GApps with the ROM itself. So this is something you will have to find separately and install manually. And that also means that it's possible to have a completely Google-less phone if you want to. Just don't flash that zip. Micro-G is a thing. Micro-G is some people saying, hey, look, let's go and re-implement all the function calls from that Google Play Services provides in an open source manner. That is a thing that is being worked on. It's not stable. Use at your own risk. One warning, Google began blocking uncertified firmware from working with GApps. And they put that in place to stop vendors who were trying to skirt the rules and just install Google Play services on devices that were not Google Play certified. That is very easily fixed because Google apparently doesn't want to completely kill the custom ROM scene. So there is a link below that you can use to just go and whitelist that specific device build. You just run an ADB command, it grabs an identifier, and you put that into the site, and Google lets you proceed and log in with your Google account and use GApps on your device, regardless of what ROM you're running. So how do you get these files? Well, XDay Developers is probably the go-to source. I have a screenshot of it up there. This is kind of what you'll see if you go to one of those forum posts for your device. XDay Developers has a lot of just independent people who build this stuff for fun. You can also go to LineageOS's site, for example. They have a bunch of pre-built binaries that you can download and flash onto your device, if you have a officially supported LineageOS device. You will need, in order to install Custom ROM, you're going to need a custom recovery. You're going to need the ROM itself, and you'll probably need some GApps package. And I didn't include this up there, but if you want to root, you'll need a root zip as well. First step you're going to want to take is to OEM unlock your device. So OEM unlocking is basically telling the bootloader, yeah, screw you, I want to run my own stuff. Just go disable the security mechanisms in place that stop me from doing that. And surprisingly, in most cases, Android lets you do that. That being said, some manufacturers make it difficult. Some manufacturers are better at this than others. For example, Samsung lets you OEM unlock your device, but it's kind of useless because even after OEM unlock, the device still enforces kernel verification. So if you're not using a Samsung kernel, yeah, or Samsung boot partition, yeah, you're not going anywhere. So again, varying levels of success. You should Google your device before you do any of this. Generally, Google Pixels and anything by OnePlus is going to have completely unlockable bootloaders that you can just click a button, reboot, run that following Fastboot command over there, confirm on the device, and all of a sudden, boom, you have an OEM unlocked device, and you can do whatever you want with it. Do note that if you hit that button, a factory reset is going to take place. The idea behind that is that you can't just, I don't know, reboot the phone, run a Fastboot command, completely wipe everything, and just steal a phone, run away, and have whatever you want. It's an anti-theft thing. It makes sense, but it can be kind of annoying because you will lose data if you do this. So after you do that, the next step is to flash a custom recovery. That's also going to use a Fastboot command, although it's going to be Fastboot flash instead of Fastboot OEM unlock. So custom recoveries are essentially a version of what is included on the device to update firmware and stuff like that, plus. Usually you have a graphical environment like this. This is probably the most common custom recovery you will see at this point. This is called TWRP. TWRP is actually really, really cool for what it is. You can ADB shell into it, run commands, install zip files, wipe things. It's very, very convenient. And it also lets you wipe, for example, the system partition, which is something that your stock recovery won't let you do. You can also create backups. So for example, if you want to go back to the stock firmware in the future, create a backup of the stock firmware, throw it on either your SD card or, and by SD card I mean your internal SD card. That is kind of terminology that has been passed down from the days when Android actually ran off SD cards, and you needed an SD card to use the OS. So when I say SD card, I actually mean the internal storage on the device and and saving to that. That can be a bit confusing, but because of historical reasons, that's kind of like the accepted terminology at this point. Next up, after you get that custom recovery installed, just go ahead and wipe your data and cache. This is a critical first step. You really, really, really want to make sure that when you install a zip file, you wipe these two things, because most custom ROMs, especially going from custom to stock, really do not like it if you're going to just flash over them. There's all kinds of incompatibilities that occur. Just do the factory reset, wipe your data and cache, don't be lazy. You'll also need to wipe the system partition and if you are installing a custom ROM. So after you wipe all those 3 partitions, you want to flash a zip. So again, you're going to need those 3 zips from before. You're going to need the ROM, you're going to need the kernel, and you're going to need the GApps. Wait, no, you don't actually need a kernel. The kernel is included in this screenshot. It's very much optional. Usually the ROM will contain your kernel. So you have your ROM and your GApps package. You're going to want to click the ROM. You say, it says, do you want to flash this? And you can say, add another zip. Click add another zip. Click on GApps. The next thing TWRP is going to say is, hey, look, do you want to flash these two zip files, or would you like to add more? And you just swipe across the screen to begin the flashing process. And voila, you've got a custom ROM. It's actually surprisingly simple. You can completely replace your system's firmware with these easy steps. So what now? You've got a custom ROM installed. Got a phone that's no longer burdened by whatever crappy code your manufacturer wrote. What do you do now? Well, you can try to give root. Remember, Android is basically Linux under the hood. So what does that mean? There's a root user. The root user is very useful. You can do things with it that otherwise would not be allowed. There are 2 ways to make root happen. There is the system way, and then there's the systemless way. The system way was usually common before Android 5. The reason for that was because Android 5 introduced SE Linux. And SE Linux is set to enforcing on any Android distribution. And if your phone is set to enforcing, if your phone is not set to enforcing, it's pretty sus, because that's, at this point, one of the fundamental protections in how Android security operates. So system root was usually used before then. You can still use it now. The thing is, you'll have to disable SE Linux. A system root is basically just an SUID binary somewhere that you try to run, bin su or whatever. You'll get a prompt up on the display by whatever root manager you're using. Click OK, and the setuid binary lets you through. Systemless, however, is quite different. And systemless, much like the name, doesn't involve touching the system partition at all. And that's interesting. So with a systemless root, you will never modify system. How do you do that? Well, systemless root works by directly injecting kernel code into the boot partition. And this kernel code does a few things. One, first thing it does is it says, hey, yeah, you see that SE Linux thing? Give me access to a context. Give Magisk, or whatever systemless root vendor you're using, access to specifically a SE Linux context that lets me do anything. That's slightly important. And then the next thing it does is inject its own code in there so that you can actually run rooted commands. Systemless root works by creating kind of like a file system mask. I'm gonna use that phrase. So it doesn't actually touch the system partition, but it does add a virtual layer that you can add stuff to. And usually that will include a bin su binary, like what the system root option had, except it doesn't actually exist. It's just a socket to whatever process Magisk or whatever systemless root you're using runs off of. Systemless is the way to go. If you're not using systemless, that in 2021, that's probably pretty sus. So speaking of Magisk, Magisk is the go-to systemless root tool right now. So Magisk provides the bin su binary. That's slightly important for apps that want to use rooted stuff. They call that. So what will happen is they try to connect to that socket. The app says, hey, look, I want to elevate myself. Connects to that socket, says Magisk hears about it and says, oh, wait, is this guy allowed to do that? Then pops up usually a diagram or some kind of pop-up box that says, hey, are you sure you want to do this? And in some cases, you can even put fingerprint authentication on it or something. Please use your fingerprint to authenticate this program to run as root. Once you do that, Magisk elevates their privilege level and goes back to the background. You can also use Magisk modules, which don't really rely on that bin su binary being there and are just kind of like modifications to the system. Examples of that include all of these things over here. that I've used in the past. Add-away is especially convenient because you can just like get rid of all ads on the system with a host-based blocker. It's basically like a pie hole, except on the device, because your phone will just go through the host file, check for a bunch of domain names. If it sees an ad, gets redirected to an IP address that doesn't exist. Camera 2 enabler enables some extra like camera API features that aren't really common for some apps, but the camera app can use. So that's incredibly convenient if you want, like, I don't know, Snapchat to look really, really pretty. Greenify, that's a battery tool that like saves your battery by either killing processes or doing all kinds of stuff to ensure that your battery isn't being drained unnecessarily. ViperFX, that's a really neat tool that lets you basically modify a bunch of sound stuff. So you can change sound stages, you can do, it's basically a sound overhauler. And I butchered the pronunciation of that, but whatever. Also, there's this little thing called Magisk Hide, and I should probably touch on that real quick. Magisk Hide says, hey, look, there's an app here that's trying to detect root. And they can do that through a variety of ways, but also, like, the bin.su socket is there, so it's pretty easy to find. Let's just remove that. And yeah, rooted apps can no longer, like, do things, but if you're trying to get into an app that has some kind of, like, primitive root detection, that's a good way to stop it. Another thing you can do is install the Exposed framework. And this used to be a separate like zip file that you had to install, but now it's just built into Magisk as a module. So you can just click a button in Magisk and enable it. And what on earth does this do? This is probably the coolest thing about rooting an Android phone. And you can probably say, well, what's cooler about having root on your phone? Well, what about having the ability to hook any module in any app on the device, including system stuff? Well, what does that let you do? OK, let's assume you are in, for example, YouTube, and you know that there is a specific function call that starts an ad. And you just hook that function call and say no, or return false. It's a thing you can do. I have used the Expose mod that does exactly that. What about privacy? Xprivacy Lua is basically an overhaul of the built-in Android privacy stuff. So when an app makes a call to say, hey, look, I want this permission, Xprivacy Lua is a more granular way to grant or deny access. And when that method call gets sent, Xprivacy Expose goes, yeet, sends it over to Xprivacy Lua, and which pops up a thing saying, hey, do you really want to let this app do this thing? And you could say, yeah, or nah, that's pretty sauce. Greenify can also work this way as well, in addition to lock screen mods, even status bar mods. I had a music visualizer on my phone at one point, and that was glorious. I really liked that. That was pretty cool. Also, this is really commonly used if you're going to go into any kind of mobile forensics. Exposed is a really popular way of doing app testing because you can just literally just say, hey, you know that method right there? Stop. And you can basically turn your phone into a debugger. It's great. So why do you not want to do this? I mean, I told you a lot of really cool things about rooting, and it's really fun. But at this point, you're basically giving super privileged access to a bunch of binaries that you just randomly downloaded from the internet. And installing operating systems just randomly from some guy on xdadevelopers.com is slightly more sus than relying on your system to come from Google. At some point, you have to determine like who you're going to trust to put software on your system, and leave software in the most, literally like the most privileged context you can get it. And everything that you're probably going to download for a mobile phone, for Android, is probably going to come from some random site. It's going to come from XDA developers. It's going to come from some random developer somewhere. There's no real way to vet these binaries except if you go to like LineageOS's site and use just their stuff, which you're probably not going to do. It definitely is a security problem. It's one of those things where even if the ROM that you're using is open source, you can still upload a different build. Like, that is a thing that has happened before. You can publish source code and compile a completely different version of that source code and claim it's the same thing. So that's pretty sus. You can mitigate this somewhat if you're willing to compile everything yourself, but who wants to do that? I've done it because I'm insane, but also like who actually wants to do that? Side note, it's actually surprisingly easy. You download about 70 gig of source code, give your computer like an hour to compile it, you're all good. But still, it's insane. So the other reason that you probably shouldn't do this for a daily driver is something called Safetynet. Safetynet is Google's way of saying, hey, yeah, that's definitely modified. That device is slightly sus. For all of the reasons I mentioned prior. Google actively tries to figure out, hey, is that a modified device? And if so, it treats your device differently. And what I mean by that is stuff like Google Pay just won't work, because that is a thing that relies on security. And Android, in order to like store your credit card information, Google has agreements that says, hey, look, we will at least try to make sure that your device is secure before you do this, and not like being exploited by some random zero-day that we don't know about. So a bunch of apps just won't work because of Google's Safetynet feature. I'm not going to go into exactly how Safetynet works, but there's a nice blog here that starts to go into it. However, it is a bit out of date, especially since Safetynet updates keep getting pushed out very, very frequently. It's a good solution, and it's a good solution for detecting rooted phones. It works surprisingly well for what it is, and a bunch of stuff can trip it. Unlock bootloader? Yeah, that's going to trip it. Any kind of pseudo binary or SU provided by anything, system or systemless root? Yeah. Weird SE Linux things? Yeah, that's going to trip it too. Contents of specific files not being correct? Yeah, that'll probably get it. Can you get around it? Yeah. Should you? Probably not. LineageOS, the main custom ROM I was talking about, has a page on their blog that says, hey, look, we are never going to try to like break Safetynet, because the second that we break Safetynet, Google says, oh yeah, you know those custom ROM guys that we're actually surprisingly okay with because we have like whitelisting things for them? Yeah, we're shutting this down. And they're right. Like, it's surprisingly sus, and running a rooted phone as a daily driver is probably not the best idea. So I kind of got into this a bit earlier, but should you do this? I mean, I really loved having a rooted device when I did. I had like 2 phones ago, I was basically rooted for the entirety of my ownership of the device. I used a wide variety of custom ROMs. I compiled them myself, added all sorts of custom mods, and I loved using it. It's kind of the same feeling that certain individuals get when they customize their Linux distributions and know that, yes, John?
You run
No, I run Red Star OS. And yes?
I can't present today. Pac-Man broke my phone.
Pac-Man broke your phone. I'm sorry for your loss. Please switch to Red Star OS. Anyway, it's the same kind of thing. Like, a lot of people really, really like certain Linux distributions because you can change everything. You know what you did. You know what your phone is running. You know what software packages are on it. It's very customized. And the same kind of thing applies here. I've never felt like I've owned a phone more than when my phone was rooted, because I could just do anything I wanted with it. It was great. But at the end of the day, with how much stuff that I require my phone to keep safe for me, my banking information, text messages, all kinds of like things I would consider sensitive, like emails, and then the question is, do I really, really trust some random guy in XDA developers that has like literally unlimited access to my system to just push an update that even accidentally contains malicious code and have my entire Android security model being taken over? That's a bit sus. So just pick up a second phone for customization. Pull in a manual. Like, I see no problems here. Emmanuel's not here. I can't add him. Oh, well, I added him anyway. But unlike certain fruit-based devices, you can actually buy cheap Android phones that will work really, really well for this. The Pixel A series is a really good option because they're cheap, and you can find them cheap used on eBay and stuff like that. any kind of OnePlus device is going to have great custom ROM support at this point. So this is a really, really good way. I know $100 to $200 is still like a kind of expensive barrier to entry, but it's probably better and more secure than running it on your own phone. So that said, do we have any questions?
For the Snapchat side of Safetynet or whatever.
Yeah.
You mentioned earlier that there was a custom app that would let you unlock access to camera. Is there some combination where the net is still good, but you can use that camera unlocker?
No, not really. So, well, again, you can get around Safetynet. People try to get around Safetynet. You can't get around Safetynet. The Camera 2 enabler was specifically a thing, I think, with Pixels was the big thing there, is that Google has a new API they were testing out for photography and stuff like that. And I haven't done a lot of research in this for a bit. I'm going off of very old information here. But essentially what happened is they denied access to that while they were testing the API. And that module would just remove that and let any app use it. And it had better results when that happened. Again, I'm not entirely caught up on that. I should do a bit more research and get back to you. I will send you a message later. I don't see anything in Twitch chat right now. Awesome.
All right, thanks, Joe.
No problem.
Yeah, honestly, very, very well done.